Hello everyone. I remain your tutor, Mr. Life Changer. In this video, I'm going to be solving questions that pertains to heat energy, specific capacity, heat capacity, latent heat, specific latent heat, and all of that. So this is a journey. So I like you to follow me. It's an interesting journey. Okay. So let's start with the first one. It says a 500-gram iron block absorbs 9,200 joules of heat energy and its temperature rises from 20 degrees Celsius to 60 degrees Celsius. What is the specific heat capacity of iron? Now, you should know that the formula for heat energy is mc theta. M stands for mass, C stands for specific heat capacity, theta stands for temperature change. Okay, so but in this question we are looking for specific heat capacity, so I can divide both sides by mass and temperature change. So it means that specific heat capacity is heat all over mass times the temperature change. Now the heat given in the question is 9,200. The mass given in the question is 500 grams, which is the same as 0.5 kilograms. So this is 0.5 times the temperature change from 20 to 60. The temperature change is simply 60 minus 20, which is equal to 40. So you have 40 degrees Celsius or 40 Kelvin. Now, this is by the way. A temperature change in degrees Celsius is the same value as temperature change in Kelvin. That's an exam question. Take note of that. So when a temperature changes, the temperature change after subtracting the value in degrees Celsius is the same value in Kelvin. So I can say 40 degrees Celsius. I can also say 40 Kelvin. I hope that makes sense. Okay, so I'm going to write 40 here. So this is going to be 9,200 divided by 20. Okay, and this is going to be equal to 460 joules per kilogram per Kelvin, because heat is measured in joules, mass is measured in kilogram, and this is measured in Kelvin. Change in temperature, like I said, can be degrees Celsius or Kelvin, is the same thing. So don't fall into the temptation of subtracting. Now let me also, for those doubting Thomas's, if you want to confirm what I'm saying, you can convert this to Kelvin. 20 degrees Celsius, if you convert it to Kelvin, plus 273, this is going to be 293 Kelvin. Then 60 degrees Celsius plus 273, this is going to be 333 Kelvin. Okay, so if you now subtract 333 minus 293, you're also going to get 40 Kelvin. You see, that's exactly what I said. The change in temperature in degrees Celsius is the same as the change in temperature in Kelvin. You know, that's what my classes are all about. You know, I try to make sure you know a lot. Now the next one here says how much heat is needed to raise the temperature of 2 kilograms of water from 25 degrees Celsius to 75 degrees Celsius, and we are given the heat capacity of water, okay, to be 4,200 joules per kilogram per Kelvin. Okay, now in this one here, the heat H is equal to simply Hc mc theta. Okay, that's the formula for heat. So the mass here is 2 kilogram based on the question. So let me just write it as 2, then times specific heat capacity is 4,200. Then the temperature change from 25 to 75 is 50, because 75 minus 25 is equal to 50. And this is going to be 100 times this 4200, then 00, and that means 420,000 joules. So the answer to this question is B. Now, but I want to digress here. Now, the specific heat capacity of water usually is given in is 4,200 joules per kilogram per Kelvin. Now, but it is also 4.2 joules per gram per Kelvin. So if it is in grams, it will be 4.2, but if it is kilogram, it will be 4,200. Please note that. Now I use this when the mass is given in grams. You know, that means I don't need to convert. As long as the mass is in grams, I can use this. I don't need conversion. And if the mass is in kilogram, I can use this. I don't need any conversion. Kindly note that. That's by the way. Now the next question says a 30 watt heater heats 1.5 kilogram of a liquid for 4 minutes. The temperature of the liquid rises by 24 degrees Celsius. what is the specific heat capacity of the liquid. Now the specific heat capacity in this case, now you use electricity to, this is a conversion of heat. There's what we call conservation of energy, that energy cannot be created nor destroyed, but it can be converted from one form to another. So in this case now, looks like a conversion of heat from electricity to temperature. If you notice, we are given 30 watts here and we are given time. So electrical energy is power times time, and the heat here is mc theta. So this is the formula we are going to use here. Please note that as long as you are dealing with electrical energy, it can be power times time, it can be IVT, it can be I squared RT, it can be V squared over RT. Any of them works. These are different formulas for Ohm's law. You can check one of my videos on Ohm's law. I did a text there. Now power times time here, the power is 300 watts, the time here is 4 minutes, which means 4 times 60, converting it to seconds, equal to, the mass is 1.5 grams. Specific heat capacity is what we are looking for. The temperature change, they've already given us the temperature change. They said the liquid rises by, that's temperature change, that's the rise in temperature, 24 degrees Celsius, which we can also call 24 Kelvin. Don't be tempted to convert it. If it is temperature change, its value in degrees Celsius is the same value in Kelvin. Okay, so I can come here and put 24. So if I cross multiply or I divide both sides, C is going to be 300 times 4 times 60 divided by 1.5 times 24. I think this would cancel this 6 times, I guess. And I think this will cancel this 10 times. This will cancel this to become 200. 200 times 10 is 2000. I hope I didn't make any mistakes. 4 in 24 is 6. 6 in this is 10. Then 1.5 in this is 20 actually. Okay, yeah, is 200. 200 times 10 is 2000. So the answer is supposed to be 2000 kilogram per Kelvin. We don't have any 2000 here, so that should be a mistake from the question. So please kindly note that. I can't see any error we made here. I hope that is clear. Okay, so the next one here has to do with heat capacity. Please, I want you to note that heat capacity is not the same thing as specific heat capacity. They are different. Heat capacity, specific heat capacity is the amount of heat required to raise 1 kilogram of a substance through a temperature of 1 Kelvin. The amount of heat required to raise 1 kilogram of a substance through a temperature of 1 Kelvin. But heat capacity, on the other hand, is the amount of heat required to raise the temperature of an object, of a substance, by 1 Kelvin. The difference between specific heat capacity and heat capacity is mass, nothing much. Okay, specific heat capacity is per unit mass, but heat capacity does not, depend on mass. That's why specific heat capacity has a unit of kilogram, joules per kilogram per Kelvin, but heat capacity is joules per Kelvin, simply joules per Kelvin. If you notice, the difference here is in grams. So we can say here that heat capacity is equal to specific, or you can say specific heat capacity is equal to heat capacity all over mass. Kindly note that is equal to heat capacity over mass. So what that means is that, we say that heat H is equal to mc theta. It means that in this case now, that H is going to be mc, let me call it ch, sorry, not mc, it's going to be ch theta, because heat capacity ch is already equal to mc. That means heat capacity, if I cross multiply, heat capacity is going to be mass times specific heat capacity. Don't forget that. So that means the heat is mc theta. Heat can also be ch subscript h theta, where this ch means mc. Okay, so heat capacity is the same thing as mass times specific heat capacity, meaning that I can always use that to replace mc in a formula. Please never forget that. So a calorimeter has a heat capacity of 60 joules per Kelvin. How much heat energy is needed to raise the temperature by 35 degrees Celsius? So we need heat. and it's just going to be CH theta. That's all. You don't need temperature in this solution. Okay, so this is heat capacity is 60, temperature change is 35, and that will give us the answer we are looking for. That's going to be 1800 plus 300, that's 2100 joules. So the answer is B. Okay, that makes sense. Now number 5 says an object absorbs 3600 joules of heat and its temperature rises from this to this. What is the heat capacity? Like I said, heat is equal to the heat capacity CH times temperature change. So now the heat capacity will just be heat over temperature change. The heat is 3600 joules, that's the heat. The temperature change from 30 to 90 is 60, okay, because 90 minus 30 is 60. So this cancels out and we are left with 60. So this is 60 joules per Kelvin. Makes a lot of sense. Now the next one says a block of metal of mass 0.4 kilogram has a specific heat capacity of 900 joules per kilogram per Kelvin. What is the heat capacity? Very simple. Heat capacity, since we are giving specific heat capacity and we are giving mass, heat capacity is simply mass times specific heat capacity. Don't forget this. So that means the mass is 0.4 kilogram and the specific heat capacity is 900. That is going to give us 360 joules per Kelvin. So the answer to this question is B. Very interesting, right? Then the next one we have here is this one says, this one is about specific heat capacity. So 4200 joules of heat raises the temperature of 1 kilogram of water by 1 degree Celsius. Okay, raises by, so that's change in temperature. If the same quantity of heat is given to 0.5 kilogram of water, what is the temperature rise? Wow, the same quantity of heat. That's serious. Okay, that means MC theta is equal to MC theta, the same quantity of heat, but I can say M1 C1 theta 1, M2 C2 theta 2 because it's not the same. So the mass by 1, if the same quantity of heat is given to this. Okay, so I think we can do something else here. We can say mass heat is equal to MC theta. We can look for the specific heat capacity. The heat is 4200. The mass, they say, is 1 kilogram. Specific capacity we don't know. The temperature change is also 1. So that means the specific capacity of that substance is 4200, is water. You see? So we can use it to find the temperature change in the other. So using the same formula, H equal to MC theta, the heat is the same, so 4200, they say the same heat. The mass in this case is 0.5. The specific heat capacity is 4200 also, that's what we calculated here, is the same specific capacity. Then because it's water, now specific capacity of a substance is the same no matter where, like water is 4200. In the case of copper is 400, it's constant. Then I can say times the temperature change here. So that means the temperature change will be 4200 divided by 0.5 times 4200, and this cancels this. I'm going to get, I think, 2, right? So 2 degrees Celsius, right? So the answer is C. Very interesting. Now the next question here says a 0.2 kilogram piece of aluminum, which is this is the specific heat capacity, is heated from this to this. Calculate the heat energy absorbed. Very simple. Heat energy is MC theta. Don't forget that. The mass here is 0.2 kilograms. The specific heat capacity is 900. The temperature change from this to this is simply 100. Very, very, very easy. That's 115 minus 15. 115 minus 15 is 100. Okay, so I think that works. It's going to give us 18,000 joules. Right, interesting. So the next one says equal masses of water. Water has the same specific, and oil receive equal amount of heat. The heat is equal. The ratio of the temperature rise of oil to water is okay, let's start with the heat of water. For water is mass of water, specific heat capacity of water times temperature change of water. Let me write MW this. That means the mass of water is receive equal amount of heat. The ratio of the temperature rise of water, equal masses. So the masses are equal. So let's say mass of water, specific heat capacity of water, temperature change of water is equal to mass of oil, specific heat capacity of oil, and the temperature change of oil. Very important. Since the mass is the same, equal masses, that means this can cancel this out, right? They are the same thing. You can divide both sides by that. Then the specific heat capacity of water is 4,200 times the temperature change of water, which we don't know. Specific heat capacity of oil is 2,100 times the temperature change of oil, which is theta O, we don't know. So we are looking for the ratio of the temperature rise of oil to that of water. So that means oil to water. Let me divide both sides by water so that you can get the ratio of oil to water. That means I'm going to divide both sides by 2,100 also. So this will cancel this here, this will cancel this here. So the temperature, the ratio of temperature of oil to the temperature change of water is 4,200 over 2,100. If you divide, that's going to be 2 over 1. 2 over 1 simply means 2 ratio 1. Very, very, very interesting. Okay, so that leads us to this one. It says 1.5 block of iron, this is the specific heat capacity, cools from this to this. How much heat does it release? Very easy. H is equal to mc theta. The mass is 1.5, specific heat capacity is 460, and the temperature change from 200 to 50, the temperature change is 150. And if you multiply that, we are going to get 103,500 joules, which is B for the answer. Okay, thank you very much. So I'm going to continue here in the next video. There are 30 questions, so we have just seen 10. We'll continue in other videos. Thank you very much. I remain your tutor, Mr. Life Changer. Do well to like, do well to share, do well to subscribe or to follow me, because it's going to be back to back. It's an interesting place for you to be. Thank you very much.